1 plus a cubed plus 3ab equal to b cubed. 1 plus a5 equal to b5. We should find a and b. A and b are real numbers. Here I have 1 a cubed, b cubed. So if I take all things to left hand side, I can say 1 plus a cubed, b cubed, left hand side negative b cubed plus 3ab equal to 0. When we have sum of three cube numbers, we can use this identity. So if I say a, for example, here 1 plus a cube negative b cube, I can say minus b cube is plus negative b cube. So it will be 1 plus, if we use this identity, 1 plus a minus b, 1 plus a squared plus b squared minus a plus b plus a b plus 3 times 1 times a times negative b, which will be negative 3ab. So here, if we add by 3ab both sides, we will reach this. It will be 1 plus a cubed minus b cubed plus 3ab equal to 1 plus a minus b times 1 plus a squared plus b squared minus a plus b plus ab. And you know here it is equal to 0 because of this part. So product of two parts equal to 0. Let's consider case 1. This part equal to 0 or this part equal to 0. At first we check this. 1 plus a squared plus b squared minus a plus b plus ab equal to 0. We multiply by 2 this part, 2 plus 2a squared plus 2b squared. I want to write it as sum of squares. Because we have a squared, b squared, we want to use ab. We should have 2ab because of this famous identity. So if we multiply by 2, negative 2a plus 2b plus 2ab equal to 0, I can write it as a squared plus b squared plus 2ab plus a squared minus 2a plus 1 plus b squared plus 2b plus 1. So it will be 0, the first part, by applying this. It will be a plus b squared. Again, if we use same identity, it will be a minus 1 squared, and here b plus 1 squared equal to sum of some squares. All of them at least 0, so when their sum is 0, we can conclude each of them should be 0. A plus b 0, a minus 1 equal to 0, b plus 1 equal to 0. From this part, a equal to 1. From this part, b equal to negative 1. And a plus b is 0, but we have two equations. We 1 plus a5 equal to b5. 1 plus a5 equal to b5. If we check, it will be 1 plus negative 1 to the 5 equal to 1. Sorry, 1 plus 1, a is 1. 1 plus 1 to the 5 equal to negative 1 to the 5. Left hand side is 2, right hand side is negative 1. So that's a contradiction. This case is not possible. So second case is what? 1 plus a minus b equal to 0. Case 2. Now we can say, if we take b to right hand side, 1 plus a equal to b. And from second equation here, we have this. So if we replace, again, replacement that I say always is important. 1 plus a to the 5 equal to b. Replace b with 1 plus a to the 5. This part we should use binomial theorem. We should memorize for n, but here we want to use 5. I only write 5. So here x is 1, y is a. So it will be 1 plus 5a plus 10a squared plus 10a cubed plus 5a to the 4 plus a to the 5. So here a to the 5, a to the 5 we cancel. 1 and 1 we cancel. So 0. And if we divide both sides by 5, it will be a plus 2a squared plus 2a cubed plus a the 4. So this part we try to factorize. It will be a times 1 plus 2a plus 2a squared plus a cubed. So if we replace a with -1, we will see it is 0. Okay, so if we factor from 1 plus a, I can say, or let me write a plus 1. I should create at first a cubed. I write a squared. So I have a squared, a cubed plus a squared. I have 2a squared, so I should write 1a. It will be plus a squared plus a. I have 2a, so I should place 1 here. 2a will be a plus 1, so 1 will be created. So we factorize this. How I understand one factor is a plus 1, because if you replace here a with -1, it will be 1 minus 2 plus 2 minus 1 equal to 0. Because -1 is a root, so a plus 1 is one factor. This way is so much useful. Okay, so because the product of them is 0, we have 3 cases. Case 2, 1. A equal to 0. So a equal to 0, then because b is a plus 1, b is 1. So if you replace a0, b1, it will be okay. Also, a0, 0 here, b1, 1, it will be okay. So we found one answer. Case 2, a plus 1. So we've checked this. Now we check a plus 1 equal to 0, a equal to -1. We said b should be a plus 1. Here we proved. So in this case, a plus 1 will be -1 plus 1, 0. So if you check again this part, b0, 0, a -1, it is okay. A -1, 1, 0. Okay, so another answer is a -1 and b equal to 0. Second answer. Now we should check last case, case 2, 3. We've checked this, now we should check this part if it is equal to 0. A squared plus a plus 1 equal to 0. What we can write it as square. If we use this identity again, I can say a squared plus a. I can write it as a plus 1/2 squared. I create a squared plus a plus 1 over 4. So I write minus 1 over 4 plus 1 equal to 0. So it will be a plus 1/2 squared plus 3 over 4 equal to 0. I know it is at least 0 and it is 3 over 4 positive, so it cannot be possible. So we found two answers.